Tonya,
Yes, ma'am.
I need to leave this meeting, but send me a text if when I leave, if make sure it's still recording. I don't know. Can you tell if it's recording?
It says the recording has started, so.
Okay. I'm going to leave. Let me know. If it doesn't, I'll jump back in and I can try to leave this up and running behind me. But
Yes,
I'm going to attempt to leave. I don't know if it'll keep recording or not.
Okay. Good morning, everyone. It's 11 o'clock. I guess we'll go ahead and get started. Welcome back to our final special NCLUG presentation for National Surveyors Week. I hope you've enjoyed yourself this week, and I did want to say thank you for being patient with us as we work through our fumbles and our glitches this week. Today's webinar will be drones for survey coming from all angles. But first, a few housekeeping details. The webinar is a presentation, so all attendees need to mute themselves. Please do not mute all. At any time during the webinar, you can submit your questions into the chat box. As time allows, Brian will be answering any of the questions during the Q&A session. However, he'll stay a little bit afterwards to answer questions if he cannot get to them during the actual time allotted. We will be recording this webinar and we'll share the link after the event. And I don't know if anybody had heard Patty earlier. She says that the videos will be downloaded this weekend and we hope to have them all available on our website on Monday. I have put in the chat box, I put the link to where the videos will be located. NCLUG is offering PDH credit to those of you who have registered on the website for this event. After the session, NCLUG will send out PDH receipts to those who have attended this live meeting. No credit will be given to those who have viewed the recorded presentation. And now I'd like to introduce Brian Flaherty, a Survey Department Manager and Drone Specialist at ESP Associates, as your presenter today.
Well, good morning, folks. Um, Glad you all are here, and I appreciate the opportunity, Tonya, to speak um, for everyone. Just a couple things I wanted to make sure that I talk about before I start my presentation is one of the things that I wanted to talk or let you guys know that this is all going to be coming from all different angles, and there's a reason for that. Is because I want you all to know that when we're in the process of looking at a site to try to do this, there's so many different things that we're going to be looking at to do a project that it's all coming from different places. So excuse the what looks to be unorganized, but it's unorganized for a reason. So all that being said, a little bit about myself. Let's see here. Um, I'm Brian Flaherty. I'm a North Carolina PLS. I am the drone manager for ESP Associates, and I've been here for 24 years. I'm also a commercial pilot for single-engine land and multi-engine land aircraft. I'm just recently I became a certified flight instructor. In November, I actually added the instrument add-on. So just a little bit more about me on my aviation background. I also am an advanced ground instructor. So it kind of helps with a good, broad, general knowledge of the FAA regulations. Obviously, I'm a Part 107 pilot as well, and because we do work in North Carolina, and it's a requirement, and I'll talk about that a little bit further in my conversations here on my slide. That I'm also a permitted UAV DOT pilot. So, all that being said, let's go to the next slide. A little bit about ESP. We're 400 employees plus. We've been in the business for a little bit more than 34 years. Our core values are quality, service, integrity. We're licensed, registered in 35 states. We have 13 offices across the United States. And ESP has been consecutively recognized in the engineering top 500 design firms for several years now. Somebody's saying they don't see any slides. Is anybody seeing any slides? Anybody else not seeing slides?
I do see the slides. Perhaps he needs to click your presentation.
I'm presenting. It says I'm presenting, and it looks like no slides here. Somebody else saying I see slides fine.
Yeah, I see them fine.
Okay. Well, we have a recording, and so hopefully the recording will show that as well. So, committing machining. Said, we'll continue on. Let me see here. So a little bit more about our current offerings. We have an MD4 3000, which is a microdrones UAV. It's 6 foot by 6 foot from rotor hub to rotor hub. Has one LiPo battery that has 21,000 milliamps. We have total 3 batteries, so we can fly consecutively. We normally have 4 batteries, but we had to retire 1 battery, and we can show that a little bit further. With small UAS services, you can work up to 55 pounds. Anything 55 pounds or lower. Our system, including the payload, is 35 pounds. That's a weight and balance thing. It can't handle more than 35. This system can't handle more than 35 pounds. So just kind of gives you an idea that there is some flexibility, but there's a lot of things to consider when you're looking at this. So what is involved with our payload? Our system, The main UAV itself is a MD4 3000. We have a Minivux DL Regal sensor on there that has a 46-degree field of view. It also carries a Sony RX1R2 42 megapixel camera. It has an Aplanix APX 20 IMU on there. And most of our flights that we plan are 80 meters above ground level. And again, I'll get into this a little bit later on why some of that stuff is important to discuss. Generally speaking, most of our collection is generally LiDAR speaking, but we do from time to time have imagery only projects that we do that tend to help us with some surveys with imagery. So I wanted to talk quickly about if you can't see the slides, maybe you look for this icon up here. Yeah. So a little bit about a quick project I wanted to talk about. And I'm going to show actually a few projects here. This project we did is in Charlotte area. We did this for a developer who was looking at doing a townhome community in this. It's about 37 hours, about 4 hours of collection. That's us traveling to the site, us setting up, us doing a bunch of other things, collecting, checking the data, making sure that we have cover, all that good stuff. And so we use a whole gamut of software that we'll discuss here in a little bit, but to kind of give you an idea of what we did is this was the site we have, fully wooded. We processed everything, we flew everything, we processed everything, and hey, Tonya, did you want me to keep on going, or you want me to hold off for a second?
Yeah, I'm sorry, Brian. I'm not quite I don't quite understand why some people can see the slides and some people cannot. I did send like a link, or I did a little screen capture of what I had to click on to see the slides. So I'm not sure if anybody was able to get to that, but some people are saying they're getting an error message when they're trying to display the content. I have to keep going back and forth to see what the comments are. I apologize for the things. So I have several people saying they can see, but I have several people saying they cannot see the slides. Brian, are you displaying it in like on another screen, or did you just share?
I'm just sharing the PowerPoint itself. I'm displaying it. I could do the whole computer if that makes it easier. I definitely can do that.
That might be the way to go, because some people are saying they're not seeing the same icon that I showed. So I'm not quite sure what their setup is and why that's an issue.
Okay, so I'm sharing the whole screen. The only thing is, I'm probably going to get these replies coming in from everybody.
Yes, I agree. Okay, so I am getting now, I see it. I can see it now. Yes, it looks like that's working. Thank you, everyone. If someone can just, if they still have problems seeing the slides, if you want to just send me a message, and we'll continue from there. But Brian, I do believe that helped.
Okay.
It looks like everybody's being able to see him.
Okay, sure. All right, so a little bit, those you can see it. I was talking about the dimensions. You can see the size of it. We're past this. I wanted to show, here it is. So this was our 37-acre site, fully wooded. The red line represents the boundary limits. We processed it. We went through our whole LiDAR processing system. The green represents the tree classification, and all I'm actually showing on that image right there is the tree classification as it overlays to LiDAR. And I know most people understand LiDAR, but you know, there's always a wow factor when you take out the trees and you can see the detail that you're getting in the LiDAR data. And you could see, I don't know if you can see my cursor down here on the screen, but the streams that you have in there. What's crazy is that you never could see that roadway cutting through the middle of the site. If you look at the image and you even look at the second slide, the middle slide, you don't see that road. And what's impressive is that, you know, that LiDAR data does see it, and you're able to actually see when you send your crews out, hey, looks like we got a stream going through there. Is there a culvert that we need to be getting in there? Did you guys locate that culvert going underneath that road? So there's a lot of features on there that you can catch, you know, those people that have been surveying long enough and say, hey, you know, there's some things that we need to look at. And what's great about this is that, you know, we used this as a case study. Out of the 508 points that we had out there, locating back a curve, locating edge of pavement, locating center line of road, locating culverts, locating outlet structures. We have a lot of points out there and a bunch of ground points to validate our stuff. And if you look, our RMSE out there on that site is 0.202. And 0.32, I believe, is what we can use to get 1 foot contours, is what we want to see to be able to generate 1 foot contours. So we're way below the operating standards we want to see for an RMSE to get that 1 foot contour. So it's a great tool. This just so happened to work out just fine for us. I believe we collected this in April, late April. So the foliage wasn't just at prime, but it was still coming in. So we were able to, it wasn't in the middle of the summertime where you're going to have full dense foliage. So it just kind of gives you an idea of what you can expect for returns. Another thing that I wanted to at least point out to you is that we are getting about 400 points a square meter with our system. With overlap, we're getting around maybe 600 points a square meter on average. Because again, we're doing 35% overlap, so in certain areas we're probably getting 800 points a square meter. So and generally speaking, we got a lot of data that we're filtering through. And so, is it the right tool for the right job? You know, it all really depends on the sensor. It depends on the lay of the land. It depends on FAA regulations. You have a lot of different things you have to consider when looking at a job. And so, before I go any further, I do want to jump into one more project here. Here's another site that we did. We did this for a developer who wanted to find out if there was enough dirt in the stockpiles to fill in the basins. And so this is off of Lake Wiley. You can probably even see a couple docks over here that's coming in off the lakes. So we went out there and we flew the site. Let me close off a couple of things here. And so as we toggle off some of the information that we're able to get, I'm gonna, I think I have that on there. I'm gonna take this off. And what you will see here, so what we see here is the area of interest that we were more or less surveying. And then if you get in here, we don't have our trees in here. Let me put in our trees. We have our trees that we have that's been classified. And obviously, if you take off those trees, I'm going to take off this too. And we should turn on our surface. Come on. All right, good. So we have our surface in there. You see how everything was done. What I love about this, again, is what we're able to get underneath the trees. This project was done in March. Leaves are starting to come in. You can actually see that in the trees themselves. You can actually see some of the leaves that you can see in there. But what I love about this, you can see even how much data we're getting on the power lines. But if you take away the high foliage, you can see in detail what's going on with the stream that's going through there. And so again, it's a great tool. It's not everything. And part of what we do, you're not going to see through water with it. So when we're out here surveying, not only do we do a couple of validation points, but we also validate the top of banks and the toes of the banks because of the hydrology that's involved with those streams. We don't know if they're going to be adding culverts in there. We just go through the whole process of locating that when we're doing a full topo. So just something to think about with the process of doing this stuff. You can fly it all day long. If you don't need to do anything with the streams, then then don't worry about it. But a lot of times we have buffers that are created based off of where those tops and toes are. And I'll even go and add that there's a lot of times that we may have that this stream may be the actual property line. And in those cases, we could actually locate the center line of that creek a lot faster than our crews could by using this LiDAR data. So just something to think about. I can actually take this surface off and look at the ground in a little bit more detail. I can get down in here and you can see a little bit more detail. I think if I add the ground in here, you can see a little bit more detail what's going on with those streams. So you may not be able to see it as well as I can from my computer, but you can get an idea on how that surface is. So I think that's going to be enough with TBC, so I'm going to close that, get back into my presentation, and I'm positive that I will have to start this from the beginning. So bear with me where I get back to the slides. Okay, so right tool for light job. We got FAA regulations. We may have projects that are next to, a lot of DOT folks will know this. You're right next to a roadway. You have to stay away from 500 feet from moving cars or people. And so there's a lot of factors that we need to look at when considering that. So, and I probably should have moved this slide. This is probably the only slide that I would have wished I moved. But one of the things that we need to consider that I wanted to add is, your pilots, we're doing commercial work. We're doing it for commercial reasons. Even if you're doing something for imagery that you want to add to your website, you're going to need a Part 107 to do that. So remote pilot license, FAA, you'll have to take a test at a PSI center. It's about $150, I believe. I like to tell people to use Remote Pilot 101. There are several other versions out there. I could just tell you that a lot of ground school, if you ever want to get into flying airplanes, there's a lot of ground schools out there. Jason Shepard with M0A is fairly good. The only thing I don't like about his ground schools outside of Remote Pilot 101 is that his fees are on a monthly basis, whereas Remote Pilot 101, you pay $150 one time and you have access to that that documentation for life. And so when there's when you're renewing your license and taking tests, it's always great to go by, especially if you haven't flown in a year, you've lost a lot of what you remembered when you took the test, and there's some things that you want to make sure that you don't get in trouble doing. This is a great way to keep up to date on that. And lastly, I want to make sure that everybody understands, not North Carolina is not the only state that requires it, but it is a state that does require you to have an additional license, commercial pilot's license, and you go through their website to get that. So it's just something to consider when you're looking at starting a drone program. Your pilots are very important. Making sure you understand regulations is very important. The system itself, there's a lot of things to consider with the systems. Microdrones is not the only systems out there. A lot of people like to use DJI, mainly because the Tree 600, maybe $23,000 to $30,000 just for the UAV, as opposed to a microdrones, you're looking at $100,000 just for the system itself, no payload. There's other options out there. There's Snoopy, there's Vapors, there's all kinds of other solutions out there. But with those solutions, you have other things that you need to worry about. You got maintenance. I can tell you that the Vapor requires maintenance every so many hours. You need to do, you need to send it away for maintenance. It can become very expensive. Some of the other problems with DJI, I don't want to call them problems, but some of the issues you may have with DJI as a user end project or product is that it's made in China. And if you're working on certain sensitive sites, some government agencies don't want to use DJI. So it's just, there's the right tool for a right job. There's many options out there. You just need to consider what will give you the best return for your money. And you may not have to worry about government things. You may not have to worry about sensitive data. You may just go out there and shoot and you're good. So a DJI may be perfect for you. For us, we didn't want to corner ourselves into a box, and so we spent the extra money and got a microdrones that didn't require as much maintenance. And so that was one of the reasons why we got that. But then there's, the other options, the Snoopies and the Vapors, is that you can carry a heavier payload, and you may have other things like beyond visual line of sight that you want to consider, or flight over people where you may need a parachute system that need to be put on there. So there's a lot of different options that you may need to consider. And the heavier the object is, the more expensive it is. Microdrone system is anywhere between, depending on the payload that you're looking at, anywhere between $240,000 to upwards to $350,000. So some of the Snoopy options you're looking at $200,000 to $300,000 just for the system, and then you got a payload that you're looking at is probably around another $200,000 to $300,000. So you could have an all-in package up to $500,000 just for a UAV system. So again, there's a lot of different options on your UAV systems. It's what's best for you. So for payload options, with LiDAR, there's Regal, the two main players in UAV LiDAR. There's others that are out there. Regal and Optech, Teledyne solution is they're both very good sensors. They're, for the most part, very equal. Regal probably has about 7 or 8 sensors now, that they have available to UAV providers that are out there. Several new ones that are out there. I'll explain a little bit more about some of the things that go on and to consider with the LiDAR options. Your IMU, it all depends on who is helping you put together your payload, because you're going to want somebody to integrate that, unless you have some mechanical engineers and some LiDAR folks. And if that's you probably, this presentation is probably not for you. You probably know a lot more about all this than I do. So, but Planix and Honeywell, which is a Novotel product now, they're both going to provide you with IMU solutions. Your cameras, we have a Sony RX1R2, which is a 42 megapixel camera. DJI has a X4S, and that's usually mounted on the Matrice 600, Matrice 200. So some of those options, usually not going to get that with a Phantom Pro 3 or Phantom Pro 4 or any type of Phantom's lower grade sensor. So, and the other thing is that you know, some of your camera options, our payload is a nadir only, straight down. It's good to have some options for oblique imagery. That gives you more of a side view. And when you're trying to create 3D models, having those oblique imagery will help you with that. So a gimbal option is always good. And again, we talked about fixed or nadir. That's part of our payload that we have. So we got some post-processing. What are you going to need for post-processing? You know, there's POSPAC for those people that are using Planix. I honestly don't know what Honeywell or Novotel is using for their post-processing. Little ignorance on my behalf, and I apologize for that. But so we use POSPAC to process the trajectories. We take it through MD Infinity, which will process the Regal RXP files and create LAS files using the POSPAC, the SBET file created by POSPAC. We'll take it through TerraMatch, and what TerraMatch does, it refines each strip for you. And what that does is, you know, every strip that we have, it will refine those strips so each strip ties together a little bit more accuracy. I mean, it's pretty close as it is now, but it takes, you know, what you may have maybe 4 or 5 hundredths of error between strip to strip, or even more, sometimes a tenth or 2 tenths, depends on winds and everything else that's going on, GPS solutions. At TerraMatch will refine those strips to make sure that it's kind of like a scan to scan or SLAM technology type stuff, and that's what it's doing. It's putting those trajectories together. And after we get that refined, we go through TerraScan and we do all the classification that goes through. You could use Trimble Business Center to do classification. It's not as detailed as TerraScan or some of the other softwares that are out there. We also have a software, in-house software suite called ESP Analyst that we can do a bunch of more things with. It's a great tool that we could sell, but I'm not here to sell our software or tell you about that. But some of the things, you know, POSPAC is about $1,500 a year to maintain that software. That software comes with the LiDAR package in most cases, unless you tell them not to do it. You may already have POSPAC in-house and you may not need it, so you could use MMS to process the trajectories. The MD Infinity comes with the LiDAR package. TerraMatch, TerraScan is I think we pay about $3,500 a year to maintain the subscription for that. Again, there's 2 different subscription packages. You can buy that a perpetual and do maintenance, or you can do a subscription package. There's Trimble Business Center. Trimble Business Center outright, if you're buying a perpetual license, it's $5,000 with the LiDAR, and you're looking at about $1,500 a year to maintain that. And ESP Analyst, Harold Rumpel will be able to tell you what those costs are. I honestly don't know what those costs are. Let's see. So One other thing, there's a tool set. I have on my next slide. I have how you can process imagery. So with imagery and LiDAR tools, Global Mapper is the bomb. I want to say it's somewhere around, I want to say $1,700 a year to have that license. You can get up with them. They have a basic model, and then they have a bunch of tools. LiDAR tools is good for certain things, but we have so many different tools that we can use. ESP is great for us, so we don't need to necessarily have those LiDAR tools. So processing imagery, there's so many different options out there. There's no perfect solution. Each solution has their niche. I will say we probably use Pix4D the most. We've used context capture. We use UAS Master. I've used Drone Deploy a long time ago. Drone Deploy works very good, and even Pix4D they're all work very good with DJI. There's a great, most softwares help integrate the solution much easier than what we do. When we process our imagery, it's a lot more, there's a lot more in the processing of the imagery than what you would normally do with DJI. Usually with DJI, the lat and long is already stored on the photo, and so it's easily, the image properties is easily imported when you bring that into Pix4D or Drone Deploy context capture. Whereas when you're using UAS Master or Pix4D or anything, when you're using our solution, we actually have to export out the event for each one of those photos, and we have to integrate that into or insert that into the program so they know what all that information is. There's a lot more information that's being stored. Yaw, pitch, and roll, and the accuracy of that lat and long is much higher. There's much higher precision in the imagery that is being done by our solution than what you would get from a typical DJI solution. There are some add-ons that will add a lot better solutions, GPS solution, IMU solution that significantly adds precision to that solution, but there's a lot of different things that you need to consider. One thing that I'd like to point out, and here's where I want to go and bring in one nice thing about Pix4D that I like is the solution of being able to export out a KML file. So here's our site. We can zoom in. I like to zoom in over here because as you zoom in to Google Earth, you can see that it's pixelated it's very pixelated. But when you bring in our Google Earth file, you can further go in and see, you can pretty much count every one of those slots that are in that grate where you can't even see that grate in Google Earth. And so the detail that you're getting from a 42 megapixel camera is just, it's pretty cool. The great thing about the Sony camera, as opposed to those folks that may be using a Phantom, the problem with the Phantoms, and I don't want to say it's a problem, it's definitely a solution. When you're working on an imagery-only product, you get distortion on the ends because it's a fish eye lens, and you get distortion on the outskirts of those of that camera, and so you have to have more overlap to help with the accuracy of something that you're flying with a Pix4D or a DJI Phantom Pro 3. So just wanted to kind of bring that up to you, mention that. see if I can get back into this slide. I'm going to have to go through there. Luckily, I don't have that many slides. But the things to talk about with the imagery, I showed you the nice thing about using Pix4D and being able to overlay that. The ortho comes in great in all of the different software packages you have out there, and drawing right on top of that is awesome. So there was one other thing, and I'll state on here, and I'll show you guys at the end. I'm going to make a note to myself to show a image only. We had a problem. We had a contractor come back to us and say that our topo was off. They flew a construction site. They just got done clearing, and they flew that site and said our topo's off by up to 13 feet in certain areas. And I want to show you what we got from them and why sometimes imagery, it's great, it's a great tool, but it's maybe not the right tool for the job. So some of the things we need to think about when we're planning flights, as I mentioned before, most of the time we try to plan flights for about 300 feet. With our sensor in the red, how are we doing on time? We're at 11:38. I'm coming along pretty good. Our sensor has a swath of about 292 feet. I'll say it's almost a 1-to-1 ratio, you can say. The sensor that I am working on trying to upgrade to, which has a lot more accuracy than our DL. There's a noise that you may get from LiDAR. There's an apparent noise that you get from LiDAR. Different surfaces provide more noise than other surfaces, so that's another thing to consider. That's why we always use conventional methods or terrestrial scanners to supplement any roadway surfaces because of the accuracies and the noise levels we get with that stuff. But wanted to talk to you about our flight planning. This slide kind of goes over a little bit on what we're talking about with flight planning. How many flights are we going to have? And so the left slide kind of shows you that we can do with the upgraded sensor that we have. We could do 3 strips if we have the new sensor, where we would end up having to do 6 strips. That's 6 different flights down a path. So as you can see, you're getting more data with less flight time, and the accuracy that you're getting from that. So sometimes you pay for what you get. You want more data. You want to be able to fly larger sites. We could fly with this type of sensor. We can probably fly 500 to 600 acre sites in a day or two, and which would be in a good time frame as opposed to flying manned flight. That's where our changeover is now with this larger sensor, more expensive sensor. You can do a little bit more with it. It's limited right here with an 80 degree field of view, but the sensor we're looking at is a Regal Bux 1DL. It actually has a 360 degree, and you can fly the side of a bridge if you wanted to, and get more detail on the side of a bridge as opposed to hanging a terrestrial scanner over. It all really depends on the accuracy that you need on some of that stuff. Again, you can stay far enough away or you can close off traffic. There's all kinds of different things that we could do to help make sure that we're staying compliant with FAA regulations. So there's just a lot of different options that you have out there. So some of the great things people don't think about when we just go out there and fly it. Well, those people who are flying now understand that there are airspaces that we have to consider. On the left slide over here, that's the land facility mapping that FAA had introduced about a year and a half ago. They've expanded on it, added Class D airspaces. But if you look at the sectional chart that I have on the right, you can see, and I don't know how many people understand sectional charts, but from 10,000 feet to surface in this circle area, you're in Class B. So if I jump up, my office or our office is right about here. If I jump up in the air, I'm in Class B airspace. However, if you look over here at this Lands facility, if you submit through the Lands facility waivers for Lands approval, you could fly up to 400 feet and be able to fly over our office. But you need and should submit your waiver through the Lands facility program that they have. You know, are you flying too close to people? Are you going to be flying beyond visual line of sight? You may have a fully wooded site where you may actually take off from an area and find, hey, I can actually see, you know, I can't actually see it. Or you should be opening up in a field area where you can see everything. There's different ways around it. You could get a lift to get up above the trees. You can get several folks planted throughout and have a system set up where you always have line of sight. But generally speaking, the pilot and the visual observer should be next to each other and working together cohesively, making sure that you have line of sight. Some things that a lot of people don't understand. The thing you're going to look at first is on the right-hand side. And today I wanted to plan a flight here in Charlotte. And man, I got 15-mile-per-hour winds. I'm good. I'm happy as anything. I can go out there and fly because most of our flights cannot happen if it's over 20 miles per hour. But if you look over to the left, the winds at 300 feet are much higher. And if you look, the gusts are actually up to 28 miles per hour. So winds aloft is what that's called, make us decide to cancel the flight. Even though the winds at surface are good enough for us to fly, winds aloft are going to keep us from being able to fly that project. So today, no flying, no flying. So just one of the things with weather. The other thing we need to worry about with our flight planning, and I love this as an example, is terrain. Especially up in the mountains. You know, people say, oh, well, you know, I got 200 acres that's on this ridge. Well, I'll be quite honest with you, the ridge is the most dangerous part, or most, I don't want to say dangerous, most accidents can happen on top of a ridge because of, on this left side, what you're seeing right there is what they call a lenticular cloud. And that's, the winds on that are very dangerous. They're coming from all angles. There's an upwards push from where the wind comes from the upward side, or coming up the winds, or coming up the mountains, and then on the downwards, it's pushing down. So you're fighting all kinds of winds, and you're going to have more winds aloft in that area when you see that type of stuff. So it's when you're in mountain areas and they say, oh, I got this perfect project for you guys to fly, the mountain areas are the most to be concerned about. Not only just because of the winds, but let's just say this little valley over here off to the right on the right picture is the best place for us to get our big 5x5 drone case, or it's really I'll say 3.5 by 4 foot drone case out. And we get the drone out and we lift off. Well, that little open area on that right-hand side is about 800 feet lower. And if you plan a mission at 300 feet AGL, guess where that aircraft is going into? It's going into the side of that mountain. And so your flight plan has to consider your terrain when you go through your flight planning mission. This is the mountains. In certain areas in Charlotte, I know it's same thing up in Raleigh, depending on where you are on the coastline, not so much. But in Charlotte and Raleigh and anywhere in the western North Carolina, you're going to have terrain that could change up to 50 to even 100 feet. And that 100 feet with trees can make a big difference on what you're collecting, especially if you decide, hey, I'm going to do a 200 foot because I want crisper images or whatever you may want to get. So there's a lot that goes into flight planning. It's more than just, hey, I'm not in airspace, I'm good to go. Well, you got weather, you got winds, you got terrain. There's a lot of different things. Oh, I didn't mean to do that. Sorry about that. Wrong button. A lot of different things to get into. Okay, hold on. Sorry. Bear with me. When you get into that. The other thing is that we here at ESP, we like to do, we document every one of our flights. There are several companies that are out there. We are right now converting to Alaris Pro. We had Skyward before. I will try to do my best not to say anything negative about Skyward. They are, I will say they are a very good firm for those folks that use DJI products. Very good integration tools. They have a lot of things coming that will really make that software work great for you. If you do not use DJI products or you're looking at other options, that's not the right thing for you. I'll just put it at that. And there's, again, it's the right tool for the right job. Skyward is a great tool for what they do, but there's a lot of things that we document. We're documenting battery life. We document what the battery was set at charge when we first started it, what it was at when we ended the flight. We're documenting wind speeds. We're documenting temperatures. There's so many things that we're trying to document to help us understand and to help microdrones, if there's ever an issue, with understanding what could have been going wrong, what may have happened. Has there been, especially if there's a battery issues where these batteries for the microdrones, just as a thought process, a battery for a DJI or Phantom Pro 3 is, I don't know, 150 bucks, 200 bucks maybe. A battery for the microdrones NB4 3000 is right around $3,000 a battery. So it can become expensive, and if you buy a battery that's dropping off very quickly, you can talk to them about, hey, I just spent $3,000, something's wrong with this battery. Let's talk this out. But flight documentation, it helps track how many hours we're using it. So when somebody says, well, how many flights have you done? How many hours, flight hours you guys have? How much experience do you really have? Well, we can provide that information to you, and I'll open up a website so I'm not going back and forth on some of the on this slide. I'll show you that. I'll show you that, and I also wanted to show you. Let's see. I wanted to show you an image of surface, and I wanted to show you Skyward. I'm going to open up Skyward to kind of give you a brief outlook. And so a good thing is I'm on my last slide. The other thing that we do, or what we have, is we have a standard operation procedure manual. Our procedure manual is about 130 pages long. There's a lot of different things that we talk about. All things being said, there's a lot that could be added to it. It's a breathing document. It is a breathing document, and so with that, I'm going to show you a couple of things here. I apologize. I know this is a Bentley users group and I'm using an Autodesk. Don't kill me. Please don't kill me. Um, so this is the site that the contractor flew, and he said that our topo was off 13 feet in certain areas. Well, after reviewing it and bringing it in, this area was a stockpile. These are trees. These are trees. And this was what they gave us and said, hey, you guys need to take a look at it. And so it's very important to understand when you're using imagery to try to give you a surface map, you are going to have to crop out some of that information and call it obscured or whatever, unless you're using some other uh, image type software that ManFlight people use. Um, so there's other software that they can use to generalize the surface, but this is not what you're going to get from a Pix4D project or a drone deploy or a context capture. You're going to have to use other software to try to get your surfaces underneath the canopy if you're using imagery. So, and the other thing that I wanted to open up is a Skyward. I'm going to use I'm going to open up a Skyward our Skyward account, so you guys can get a chance to see kind of what we're looking at on here. Let's see. All right, beautiful. So we have, it tells you all the log flights we have. That's just the log flights. And we've transferred over, we're starting to transfer over to a new software, so it doesn't have actually all of our logged flights. We've done some work for North Carolina Emergency Management, so we had a bunch of different aircraft that we were using, but you can see that there's a lot of different things that are going on and documented in the operations that will help you identify what's going on with each flight. Plus, you know, it's great logging it, because when your client says, hey, or you have new clients that are coming in and say, well, what kind of projects have you had? This is a great way to document it. It also will track your pilots. If they're up and due for renewal, this will help them keep current with all that. So all that being said, I think I have time now for some questions. Tonya, did you want to funnel through some of these questions? You want me to just answer? You want me to answer that?
Brian, I'm echoing and I apologize for the stutter there. You're welcome to look through. I didn't see any questions directly. That was a lot of information, and I know it might take some people some time to digest it. It was some really good information. Is there anything, do you have like a typical question people ask when you're doing a presentation?
No, and I know there is a lot to filter through, there's a lot of information, and that's, I could speak for hours on what you need to watch out for. I mean, if you're buying a drone, I will say there's more to buying a drone than buying the drone. You know, most people, when they look at it, I could, you know, it's like, well, what else do you need to do? Well, when you're out there and you have a large site, you know, you need batteries. And so what can you do to charge a 21,000 milliamp battery? Well, your car that may have an inverter on it isn't going to work it. You need generators. And so one of the things that I would suggest, what we did for redundancy purposes, we actually bought two 2300 Honda generators, just in case one generator went down and we still had a second generator to use. But we have two Honda generators that we couple and we use as a source of energy to recharge our batteries when we're out there on site. So the general idea, one of the questions, general idea for start finish costs for a micro drone setup, software payload, honestly, depending, it really is dependent on the sensor. So I'll give you my 2 cents, especially the way the sensors are going right now. When we first bought our DL was great because it had a lot of different options, or it had a lot of points in relationship to the Minivux One. Minivux One and the Minivux DL are essentially the same sensor. The only thing that's different is it takes that 360-degree profile that it's taken and it points it downward. And so all that energy that it's getting is going down to a 46-degree point of view. And let me see if I can open up my so if you look at this sensor.
Note number 1 and 3 and 4, and then I'll wait for anybody else's comment.
Somebody's mic is on here. Anyway, there's a 45-degree point of view, and so it forces those points downward as opposed to outward, and so you get a lot more points in that corridor. That being said, now with Regal sensors that they have out there with a micro drone setup, you can now get a Minivux 3, or again, I would probably spend the extra $100,000 on a sensor, especially if you're looking at a program. But again, every program is going to be different. I personally would like to see the Bux 1 because of the noise that we're getting in the data. The micro drones, if you're getting a Minivux 2 with software and all that good stuff, like Gus mentioned, maybe $265,000 is probably a good number to look at. It could go up to $350,000 when you consider everything else that you need to get to. Drone for small projects, 5 acres or less. So, one thing I didn't really talk about were panel placements. And, a lot of these vendors will talk about, well, you can go and fly these sites without any GCPs or anything like that. Well, most surveyors will go and tell you, we'd like to know what our data really is. And so there's a validation process that we go through. There's still panels that we're putting down. There's a lot going on that you need to consider. I honestly wouldn't say a 5-acre project is really a UAV project. When you look at what it's going to take for you to process everything, as opposed to you going out there and flying it, honestly, a 5-acre site may be just a day's worth of work in the field. Especially when you consider utilities and all that good stuff. Now, that being said, there may be a lot involved in that. It may be one of those things where you really just need the client's willing to pay a little extra. Honestly, I feel based on the amount of work we've done with the UAVs, anything 10 acres and less, honestly, you're probably better off doing it conventionally. Again, it's the right tool for the right job.
Okay, Brian, it's 12 o'clock. It's actually 12:01 now. I know that once people start digesting all of this information, they may be coming up with more questions. I think ideally, if I could have everybody submit their questions through the events, email events@nclug.com. That way I can get all that information to Brian, and then I can get all those answers to everyone who participated in this webinar. Are you okay with that, Brian? If I just give you the questions all in a lump sum?
Yeah, absolutely. Or I mean, they can email me, Flaherty at Yahoo, or I mean at ESPassociates.com. But yeah, I mean, I'm here. I'll be more than happy to answer all those questions that anybody may have.
Okay, and thank you again for presenting. This was a lot of information, and I think it's just going to take a little while for people to digest everything. I wanted to, again, thank everybody for attending today. Please remember that the PDH credit receipts will be sent out soon. As far as this concludes our National Surveyors Week. And I do want to, again, extend an invitation to everybody to send all your NCLUG topics, both surveying and engineering, through events@nclug.com. Be sure to tell everybody that you know about becoming an NCLUG member. It's free, and that way they can join and they can get information and emails about upcoming events. Thank you, everyone, and that's all for this week, and I hope you guys have a great weekend. Thanks, Brian. I appreciate your time.
Yeah, thank you, everybody.